All right, so we're going to talk about functions. Now, before we talk about functions, we need to talk about relations. All right, relations. Okay, so a relation, the definition of relation, is a set of ordered pairs. A relation is a set of ordered pairs. So an example of a set of ordered pairs is this. All right, so this is an example of a set of ordered pairs. So notice that it's written as a set, the braces, and then these points are ordered pairs. So this is a set of ordered pairs. That's what a relation is, a relation set of ordered pairs. The lines that we drew earlier, all those were relations as well. The graphs, the lines, the parabola, whether did this, it open down, the absolute value, all these are relations. They're relations because the points are a set of what? Ordered pairs. So these are examples of relations. A relation definition says a set of ordered pairs. So it could be written as a set of ordered pairs just like this. It could be listed in terms of a graph. Your graph could look like this as well. It could just be, you see these points right here? This ordered pair, how many points are in this set right here? 1, 2, 3, 4, 5. There are 5 points, right? So instead of writing it like this, I could graph the points. And so my points were what? 2, -3. So there's one of them. My other point was 4, 0. Here's the other. My other point was -2, 5. And my other point was -1, 3. All right? So I think I did all of them. -1, 2. I forgot 1, 2. 1, 2. All right. So this is also a relation because it is a set of what? Ordered pairs. All right. Now, 1, 2, 3, 4, 5. Right here. So notice that this relation right here has how many set of ordered pairs? No. An infinite number. All these are ordered pairs, right? How many are there? Infinite number. Okay? This has how many set of ordered pairs? An infinite number. This relation right here has how many set of ordered pairs? 5. A relation could also be listed as a mapping. And a mapping kind of looks like this. So you have an input and then you have an output. You have an input and an output. And for each input, you're attaching to it an output. So you do something to that input and you get an output, whatever you do to it. So let's say that when my input is 2, my output becomes, let's say, 5. If my input, let's say, is -2, my output, let's say, is 0. I'm making this up. Just telling you what a mapping looks like. This is an example of a mapping. You have an input, you have an output, and for each input, you're attaching to it a output. You could have this being, let's say, 6, and let's say my output is also 0. So your input could have the same output. Doesn't have to be different. your input, the same input, let's say 6, can have two different outputs. Let's say 4. All right? But regardless, this is a mapping because you have a set of inputs and a set of what? Output, and then for each of those inputs, you're attaching to it, doing something to it. Whatever you may be doing to that input, you're attaching to it an output. But those are all relations. You're going to see this in that handout I gave you. All these things you're going to see. So everything in that handout is a relation. Everything that's there that I gave you, all those are relations. Because each one is a set of what? Ordered pairs. Now you want to find different things about those relations. So let's talk about a function now. A function. So you know what a relation is. A relation by definition is a what? Set of ordered pairs. That's what it looks like. A function. Let's talk about a function. A function is a relation. So it's a special relation. A special relation. Now here's why it's special. For each x coordinate, there can only be one y coordinate. That's the definition. For each x, there's got to be what? Only what? One y value. That's what it says. And then it would be a function. Most of what you're going to do from now on and next semester will be functions. We talk about functions all the time. All right. So a function is a relation because a function is going to be a set of ordered pairs. Now, one thing I forgot to mention also is that a relation can also be written like this. Right here. So an equation is a relation. Because couldn't I use a t-table and get an x and a y? Mm-hmm. So I would get a set of ordered pairs. So these equations that we graphed, that first two worksheets, those were relations. Those were relations because each one was a set of ordered pairs when I graphed them. All right. Okay, now let's take out that handout I gave you. And let's do the first one. It's on page 1. Now remember a function. Remember the definition of a function. For each x, there's got to be one y. Okay, now, remember we talked about input and output? So the x coordinate, the set, note, the set of x coordinates, which sometimes we call the input. I'm going to put this parentheses, input. The set of x coordinates is called the domain. So the domain is a set of what? X coordinates. Well, if the domain is a set of x coordinates, what do you think the range is? Set of y coordinates. So the set of y coordinates, which we'll call the output, is called the range. All right. So the set of x coordinates is called the domain, and the set of y coordinates is the range. Knowing those things will get you through most of this worksheet, most of this handout. All right? Okay. So look at page 1 that I gave you. Now, the direction says this. A set of ordered pairs is given. Now, for one thing, do y'all agree that everything on these pages, that they're all relations, right? Mm-hmm. Okay, they're all relations. The thing is, though, not all of them are functions. But they're all what? Relations. In order for a relation to be a function, for each x, there's got to be one y. That's what makes it a function. All right, but they're all relations. All right, now it says this. For each relation, determine the domain, and then determine the range. And then also determine if the relation is a function. Okay? All right, well, first of all, let's do the domain first. Now, what I need for you to recognize is this. This relation is a finite set of ordered pairs. Finite means I can count. This relation is a what? Infinite set of ordered pairs. I can't count how many there are. It's an infinite number. Finite, because how many are there? How many points? 5. How many are there? Infinite. Okay. So, first of all, do y'all agree that this is a finite set? Okay, since it's a finite set, you're going to write your domain as a finite set. So it's going to look like this. Domain, you're going to say D equals a set, brace, use braces, just like this. And then all you do, remember, is that domain is a set of which coordinates? X. You list your X. If the X's occur more than once, you list it once. You understand? If X's occur more than once, you list it once. It does not have to be in numerical order. Just write it as you see it. It doesn't matter. So what is my domain here? It consists of what X coordinates? -2, comma, what's the other one? 0, comma, what's the other one? 1, comma, what's the other one? 1, the other one's 1, but I already have it listed, right? Okay, go on. 2, comma, and 3, comma. So that's your domain. So your domain is a set of those X coordinates. No other X coordinate is in that relation. It's only those X coordinates. All right, let's talk about the range. The range then will be the set of Y coordinates. And again, you list the Y coordinates once. So what are they? 2, 5, 6, 7, -1, and we already have 2. Okay? All right, so it's easy to determine the domain and range of a finite set. Before we come back and talk about whether it's a function or not, let's go to the next one and find the domain and range. Let's go to the last one. Let's do the next one because of the room. I don't have much room left. So let's do the domain of this one. Domain, range. What's the domain? 0, 1, 2, -5, and 3. Y'all agree? And what would be the range? -5, 3, 2, 4, 6. Again, make sure you put it in brace. Not parentheses. Notice, did I put parentheses on the outside? Those are not parentheses. Those are braces. Make it look like what you see here. Right here. Okay? Now let's talk about the whether they're functions or not. All right. What I would do to help me determine whether it's a function or not is I would redo these as mappings. These are called what right here? Those are mappings, right? Those are mappings. So to determine if it's a function or not, I would write these as a mapping. So for example, I'm going to call this number 1, this 2, and this 3. 1, 2, 3. 1, 2, 3. All right. So let's do number 1 first. So number 1, do a mapping. It helps if you do a mapping. Now look how you're going to do this. You're going to draw 2 ovals like this. This is your domain. Your input is your domain, and your output is called your range. So I have domain and range like this. Domain is on the left, range on the right, just like a T-table, right? Mm-hmm. We did the T-table. What was that first column? X, and what was the second column? Y. Make some connections. It helps you make these connections. All right, now here's what I would do. When x, go to each point. When x is negative 2, writing down negative 2, what is my y value? 2. So draw an arrow like this. So when x is negative 2, it gets mapped to 2. Now let's do the next one. When x is 0, it gets mapped to what? 5. Just like this. Just do it like that. If x is 1, it gets mapped to what? 6. When x is 1, now you remember, just like when we did the set, we only listed once, right?
Right.
Do the same thing with the mapping. Only list it once. Otherwise, you're going to mess up if you list it again. I already have 1, right?
Mm-hmm.
But it is also getting mapped to what? 7. Just like that. When x is 2, it gets mapped to what? Negative 1. And when x is 3, it gets mapped to what? 2. So there's your mapping. So do the mapping first. It does help. It helps if you do the mapping. Here's why. All right, let's talk about the definition of a function. What's the definition of function?
Set of one.
No, that's a relation.
Special relation.
For each x, there's only one y. All right, so let's go through each x. When x is negative 2, do I get just one y value?
Yes.
Yes. So far, we're good. When x is 0, do I get just one y value?
Yes.
Yes. So far, we're good. When x is 1, do I get just one y value? No. I get how many y values? 2. So right away, this is not a function. So not a function, not a function, since, here's why, since when x is 1, there are how many y values?
2.
There are 2 y values. According to the definition of function, for each x, there's got to be what? 1 y. So that's not a function. It's a relation, but it's not a function. For each x, there's got to be 1 y. Notice it fails because when x is 1, how many arrows do you see coming from it? 2. You see right away, there's how many? 2.
That relation is failed.
Okay? Number 2. What now?
So the whole thing is.
The whole thing's not a function. All right, next one. Number 2. X, y, domain range. When x is 0, what's my y value? No, no, no. When x is 0, what's my y value? We're on the second one. When x is, oh, I see what you're saying. Yeah, you thought I was going to number 3. That's fine. I was doing number 2 though. Yeah, you're fine. When x is 0, what's my y value? Number 2? 1. When x is 2, what's my y value? Negative 1. So far we're good, right? Because for each x so far, for each x, how many y values do I get? 1. When x is 3, what's my y value? 2. When x is 4, what's my y value? 2. It only lists it 1. So notice, see that 4 going to that same 2, right? When x is 5, what's my y value? 3. And when x is negative 5, what's my y value? 1. You already have it, so don't only list it once. Okay? All right. So let's go back and ask ourselves, is this a function? For each x, there's got to be what? 1 y. So ask yourself, when x is 0, do I get just one y value?
Yes.
Yes, it's 1. When x is 2, do I get just one y value? Yes, it's what? Negative 1. When x is 3, do I get just one y value? Yes, it's 2. When x is 4, do I get just one y value? Yes, it is what? 2. You see, you got to use the definition of function. For each x, there's what? 1 y. The y can occur more than once for an x, right? All right. So when x is 5, what's my y value? It's just 1. It's what? 3. When x is negative 5, what's my y value? It is just 1. It is what? 1. So it is okay for multiple x's to have the same y value. So, question. It is not okay for the same x to have what? 2 y values. That's why you got to ask yourself the definition of function. For each x, there's what? 1 y. So this is a function. This is a function. Number 3. When x is 0, what's my y value? Negative 5. When x is 1, what's my y value? 3. When x is 2, what's my y value? 2. When x is 0, what's my y value? 4. Right away you know it's what? Not a function. Because when x is 0, how many y values do you have? 2. When x is negative 5, what's my y value? 6. And when x is 3, what's my y value? 4. So is this a function, not a function? Not a function, because
Have more than one.
when x is 0, you have how many y values? You have 2 y values. Okay? So when x is 0, you have 2 y values.
You
Now-
had to write 4 2 times.
Huh?
How you got it 2 times on them?
Before twice.
Oh, you're right. Yes, thank you. So I only listed once, so you would have said this, right?
Yeah.
But the 3 is fine. When x is 3, you still have what? 1 y value. The issue was that x had how many y values? 2. But yeah, thank you, because you do only want to list it once. All right, let's look at this one. Tell me. You all know how to find the domain and range, so I'm not even going to worry about that. Is this a function, not a function?
It is.
It's a function, because for each x, how many y values did you get? Just 1. So it's a function. Over here, is this a function, not a function? It's a function, because for each x, when x is 1, what's my y value? 1. When x is negative 1, what's my y value? 1. When x is 0, what's my y value? 1. Negative 1. When x is negative 3, what's my y value? 6. When x is 3, what's my y value? 6. For each x, there was what? 1 y. So it's a function. It is okay. See how that negative 6 occurred twice for different y values? It's okay for different different x values to have the same y value. Now right here, is it a function, not a function? Not a function. Right away, this fails and this fails, right? Because when x is 1, how many y values did you have? 2. According to the definition, it can only be how many? 1. So that's not a function. Okay, not a function. All right, now next class period, we're going to do this. Now we're getting in, you see right here, those were finite sets right here. They're all finite sets, right? And so it's kind of easy to determine if it was a function or not, and also easier to determine domain and range. Because the domain is just a set of x coordinates, the range is a set of y coordinates.
I have to get to work. I got work in like 10 minutes.
Okay. All right. So when we do the graphs, you're going to learn something about what's called the vertical line test. So some of you may remember those words, vertical line test. So vertical line test can help you with graphs to determine if it's a function or not. All right, but we'll do that next class period. All right, what I need to give you though, I think